Biological machinery 2-mark question and answer with explanation that is used for TNPSC and TNEB and semester exams. 21st question. If Ia be the armature current, then speed of a DC shunt motor is answer A, independent of Ia. 4 choices are given. Armature current increases leading to a slight decreases in speed. The speed of a DC shunt motor is inversely proportional to the armature current Ia when the flux per pole pi is constant as expressed by the formula n proportional to V minus Ia Ra divided by pi. Because the flux pi in a shunt motor is nearly constant, an increase in armature current Ia leads to a greater voltage drop across the armature Ia/Ra, resulting in a slight decreases in the motor speed. So answer independent of Ia, n proportional to 1 divided by pi, proportional to V minus Ia/Ra divided by pi. N is proportional to V minus Ia/Ra divided by pi. V proportional to pi, nearly constant for a DC shunt motor. This formula indicates that as the armature current Ia increases, the voltage of Ia/Ra across the armature increasing, leading to a slight. 22nd question. In case of the back EMF and the speed of a DC motor are double, the torque developed by the motor will be answer B, reduced to 1/4 value. That is reduced to 1/4 of its original value. 4 choices are given. Reason we will be seeing in next page. Answer is 1/4 of its original value. That is 1/4 of its value. Reduced to 1/4 of its original value. Reason we will see in next page. This happens because the armature current, which is directly proportional to the torque, T is proportional to Ia, is roughly held when the back EMF doubles, and the torque is proportional to the square of the armature current, T proportional to Ia. However, if the armature current is rough by or held, the torque becomes approximately 1/4 of its original value. Since torque is proportional to the square of the armature current, T proportional to Ia square. Armature current Ia is find out from equation Ia/Ra is equal to V minus Eb. Eb is back EMF. Ia is equation is equal to V minus Eb divided by Ra. The current drawn by the motor is given by the formula Ia is equal to V is the applied voltage. Eb is the back EMF. Ra is armature resistance Ra. Since the back EMF Eb increases, the term V minus Eb decreases, which in turn decreases the armature current Ia. Ask questions and speed effect of doubling speed. When the speed doubles, the back EMF Ab also doubles. Because back EMF is directly proportional to the speed, back EMF Eb proportional to N. N is speed, Eb is back EMF. 23rd question. At the instant of starting, when a DC motor is put on supply, it behaves like answer B, a low resistance circuit. Reason. At the instant of starting a DC motor, answer B, a low resistance circuit. Reason. At the instant of starting a DC motor behaves like a low resistance circuit, which causes it to draw a very high initial current. This large current is often referred to as the inrush or starting current.